Welcome to the deep dive. Today, we're tackling a really prevalent issue,
hmm
the technology overload in our cars.
hmm
We're sort of zeroing in on those in-vehicle infotainment systems, the navigation, the music, all those screen,
Distractions, yeah.
and how they can unfortunately divert our attention from driving, which, well, obviously increases accident risks. Finding a safer way to interact is a serious challenge.
It is indeed. And the focus of our deep dive today is a compelling recent study. It looks at a promising new direction.
Oh, yeah.
They investigated combining a head-up display, or HUD, the kind that projects onto your windshield,
Right.
with a specific kind of auditory feedback called spear cons.
The greater cons.
Yeah, they're like compressed speech sounds. And it's all designed to help us navigate menus using simple gestures.
Okay, let's break this down for everyone listening then.
Ah.
The fundamental problem here is figuring out how we can, manage things like changing music or getting directions without constantly taking our eyes off the road.
Exactly. Even those quick glances can have pretty serious consequences.
Right.
So this study cleverly tested 4 different ways of presenting information and feedback to the driver.
4 ways. Okay.
They looked at a HUD with spear cons, a HUD without spear cons,
Yeah.
a traditional head-down display, the kind you typically see in the center console,
The usual screen, yeah.
also tested with spear cons, and then that same head-down display without any sound cues at all.
So 4 distinct setups to really pinpoint what works best and, well, perhaps more importantly, what doesn't.
Precisely.
So for you listening, what we're trying to understand today is how these different combinations display type, sound feedback, how they affect a driver's ability to drive safely.
Their awareness, too.
Their awareness of what's happening around them.
Yeah.
Yeah, and even how easy or difficult they find each system to use.
Ultimately, this research aims to guide the development of in-car tech that's actually safer and, more intuitive for all of us on the road.
Because at the end of the day, our priority is getting from A to B safely.
Absolutely. And speaking of safety, let's delve into the core issue this study is addressing: driver distraction. It's a really significant factor in accidents, isn't it?
It really is. The numbers are quite stark. Car accidents remain a leading cause of death worldwide.
It's sobering.
And more research is pointing to these in-vehicle systems, things like navigation apps, streaming services,
Yeah.
as major contributors to this distraction.
Our attention is just such a limited resource.
Totally. And these systems often demand more of it than is safe while we're driving.
We've seen previous attempts to tackle this, haven't we? Like voice control was hailed as a hands-free solution.
Right.
And some modern cars now have sensors that try to detect when a driver's attention is wandering. How effective have those actually been?
Well, there's certainly steps forward. Voice control can reduce the need to physically touch things. But it's not always perfect, is it?
No, recognition can be iffy.
Exactly. Voice recognition can be unreliable, and complex commands can still be clunky to use. Driver distraction detection is also helpful, giving warnings if you seem inattentive.
But still.
But the study we're focusing on explores another interesting possibility: interacting with the car using gestures.
Exactly. The idea behind gesture control is that it might reduce the physical movements required and, crucially, the time our eyes spend looking away from the road.
Less reaching and tapping.
Yeah, earlier studies suggested that gesture-based interaction could be a less distracting way to control in-car systems compared to, fiddling with touch screens or buttons.
That makes intuitive sense.
Yeah.
But I recall hearing about something called multiple resources theory.
Mm.
How does gesture control fit into that? Could we just be swapping one type of distraction for another?
That's a really insightful question. Multiple resources theory suggests that if you try to perform 2 tasks that rely on the same kind of mental resources, your performance on both will likely suffer. So, with gesture control while driving, you're still using your hands. That's a manual resource.
As a gesture, yeah.
And you often need to look at the screen to see if your gesture worked, which engages a visual resource.
Right.
This could potentially clash with the manual task of steering and the visual task of observing the road. It's like trying to pat your head and rub your stomach at the same time.
If both demand the same kind of attention, it gets tricky.
Exactly.
Right, so we're still using our hands to steer and our eyes to watch, and now we're adding hand waving and looking at a screen to manage the infotainment. That still sounds potentially problematic.
It does. And that's where the role of auditory feedback becomes so important.
Ah, the sound cues.
Research has consistently demonstrated that using non-visual cues can be very effective in reducing driver distraction. By using our sense of hearing, we can receive information without competing for that crucial visual attention.
So instead of having to look at a button, you might hear a sound confirming you've made a selection. That seems like it would definitely help.
It does help. But the study also mentioned a limitation that drivers still have this tendency to look at visual displays anyway.
Even with the sounds.
That's a key point. Even when helpful sounds are provided, there's a natural human inclination to want visual confirmation.
You want to see it worked.
Exactly. Drivers might not fully trust an auditory-only system and will often glance at the screen anyway. This visual scanning is itself a form of interference when you're trying to focus on driving.
Okay, so we're back to the visual aspect then. And this leads us to the distinction between head-down displays and head-up displays, doesn't it? Where you're looking makes a huge difference.
Precisely. Head-down displays, those typical center console screens, are located outside the driver's primary useful field of view.
That cone in front of you.
Generally considered about 4 to 30 degrees directly in front. When you look at an HDD, your eyes have to refocus and your attention is drawn away from the forward view.
Right.
Head-up displays, on the other hand, project information within that useful field of view, often onto the windshield itself.
So it's right there.
Which allows for much quicker and easier switching of focus between the HUD and the road ahead.
So the fundamental idea with a HUD is that the information is sort of superimposed on your view of the road,
Right.
making it a less drastic shift in where your eyes are directed.
That's the core principle. Because the HUD is transparent, it doesn't block your view of oncoming traffic or hazards, letting you maintain better awareness while still getting important info.
Okay.
This is why the researchers in this study hypothesized that a HUD would be a more effective tool for improving driver safety and situation awareness, especially when combined with gesture control.
All right, that gives us a solid foundation.
Okay.
Now let's dive into the specifics of this study. What exactly did their gesture interaction design entail? How did it work?
Well, the gesture system they implemented was based on some prior work. It involved 4 fundamental gestures: making a fist to activate the system,
Okay, like turning it on.
hovering your hand horizontally or vertically to highlight and select a menu item, swiping your hand to switch between different menu screens,
Like pages.
and finally tapping your hand to confirm your selection. It's designed to be fairly intuitive.
It does sound straightforward enough. What about the visual feedback on the displays themselves, both the HDD and the HUD? How did those look?
Both display types operated with 3 distinct user interface states. First, there was a standby mode. On the HUD, this showed a subtle menu grid with a gray background to maximize transparency
Keep it out of the way.
and minimize distraction when not in active use. Once the driver made that activation gesture, the fist,
Right.
the system transitioned to the Interact UI. This presented a clear 2x2 grid of menu selections.
Some great.
As the driver moved their hand, the currently highlighted selection would change color for visual feedback. And importantly, in the conditions with auditory feedback,
The spear cons.
a spearcon, that compressed speech sound representing the highlighted item, would also play. Think of it like a very short voice message for a specific command, not just a generic ding.
Okay. And how did a driver navigate through different menus or get important alerts?
To switch between menu pages, a swiping gesture would trigger a new set of options. This action was accompanied by a distinct auditory icon. They described it as a short wind pass sound to provide non-visual confirmation of the page change. When a selection was confirmed with a tap gesture, 2 musical notes with an increasing pitch played as a confirmation icon, a more abstract sound cue.
Got it. Different sounds for different actions.
And finally, there was a critical warning UI. This was designed to immediately override the current display if a potential hazard was detected in the driving simulation.
Like a pedestrian.
Exactly, or an emergency vehicle. When this happened, the ongoing selection process was temporarily interrupted to grab the driver's attention.
That sounds like a well-integrated system, multiple layers of feedback.
Yeah.
Now let's circle back to spear cons. You mentioned they were chosen for a reason. Why those specifically?
Absolutely. Spearcon's speech-based earcons are essentially compressed snippets of speech. The researchers chose them based on findings that they tend to be more easily learned and understood,
Learnability?
and also more concise compared to other types of auditory feedback like full text-to-speech, simple beeps or clicks, or more abstract earcons.
Text-to-speech can be slow, right?
Yeah. It can be too lengthy and verbose for quick interactions while driving, whereas auditory icons and earcons often require a period of learning to associate the sound with its meaning.
You have to figure out what the beat means.
Exactly. Prior research indicated that spear cons are user-friendly and provide accurate feedback, which can lead to better navigation speed, accuracy, and how quickly users learn the system.
So instead of a potentially distracting robotic voice saying a full word,
You get a brief, almost musical representation of that word, quicker, less intrusive.
that's clever. Now, how did they actually put these different conditions to the test? What kind of setup did they use for the driving simulation?
They utilized a medium-fidelity driving simulator called NADS Minisim. This included 3 large screens for a wide field of view,
Immersive.
along with a physical steering wheel, an adjustable driver's seat, and foot pedals to create a realistic driving experience.
And the HUD.
For their custom head-up display, they used an acrylic board with a special coating positioned between the driver and the central screen. An iPad Pro then displayed the HUD graphics,
Projecting onto the board.
allowing participants to see both the projected info and the simulated road through it.
Okay. And where was the traditional head-down display situated in this setup?
The HDD was simulated using a small computer monitor positioned to the right of the simulated dashboard, tilted upwards at 30 degrees to mimic typical placement.
Like in a real car.
And to capture the hand gestures, they used a Leap motion controller mounted near the HDD, adjustable for arm length.
And the voice prompts.
They use an online text-to-speech tool to generate the voice commands telling participants which item to select. Crucially, to gather detailed eye gaze data,
Where they were looking.
they employed Tobai Pro Glasses 2 wearable eye-tracking devices.
Wow, quite the setup. So what was the actual experimental process? How did they ensure each participant experienced all 4 conditions fairly?
They recruited 24 licensed drivers. The design was within subjects, meaning each participant experienced all 4 conditions: HUD with sound, HUD without sound, HDD with sound, HDD without sound.
Everyone tried everything.
Yep. They drove through 4 different simulated driving scenarios, each lasting about 6 minutes. During each drive, every 30 seconds, a voice command prompted them to use the gesture system to select a specific menu item.
So regular interaction tasks.
And to enhance realism, they also incorporated pre-programmed hazard events, pedestrians, emergency vehicles, that sort of thing.
Keep them on their toes.
The order in which each participant experienced the 4 conditions was carefully randomized and counterbalanced to minimize any potential order effects or learning biases.
That makes sense. Controlling for those variables is crucial. So they're driving, interacting with the menu, hazards pop up. How did the researchers actually measure how well the drivers were doing in each situation?
They used a really comprehensive set of measures. First, the Situation Awareness Global Assessment Technique, or SAGAT, questionnaire.
Second. Okay.
It's a well-established method for evaluating awareness at 3 distinct levels. Level 1, perception, SA1, is about whether the driver noticed critical elements, like hazards.
Did they see it?
Basically. An example question might be asking what they saw on the road. Level 2, comprehension, SA2, examines if they understood the significance, like, did they realize the pedestrian might step out?
Understood the danger.
And level 3, projection, SA3, looks at whether they can anticipate future events and plan actions, like predicting they'd need to brake.
So SAGAT gives a detailed picture of their understanding of the whole situation. What about how demanding the tasks felt to the drivers?
For that, they used the NASA TLX, or Task Load Index.
Yes, the workload measure.
It's a widely used subjective assessment tool. It measures perceived workload across 6 dimensions: mental demand, physical demand, temporal demand, how rushed they felt, their self-rated performance, effort invested, and their overall frustration level.
That makes sense. Important to gauge not just objective performance, but also how taxing each system felt. And then I assume they also looked at the objective performance on the menu navigation itself.
Absolutely. They meticulously recorded the time it took to make a correct selection after the prompt and the overall accuracy.
Speed and correctness.
Plus, they analyzed the rich data from the eye tracking glasses to understand exactly where participants were looking.
The fixations and saccades.
Exactly. Fixation duration on different areas, road, HUD, HDD, and the frequency of saccades, those rapid eye movements. They even defined specific metrics like selecting fixation.
Time spent looking at the menu while selecting.
And in between saccade, which refers to the eye movements between looking at the road and the menu.
Gotcha. And finally, I'm guessing they gathered data on how the interaction methods influenced actual driving performance.
Yes, the simulator recorded objective driving data like average steering wheel angle indicating steering stability,
It's a mood test.
and average lane center offset, measuring how much the vehicle deviated from the center of the lane.
Lane keeping.
And lastly, after each condition, participants completed the System Usability Scale, or SUS questionnaire.
SUS score, right, for preference.
It's a standardized measure of perceived usability, reflecting their overall preference for each interface.
Wow, they really covered all bases.
Hmm.
So after all that detailed investigation, what were the main takeaways? What do they actually find?
The study yielded some really fascinating results, and, well, as often happens, there were some interesting trade-offs.
Okay, let's hear them.
Let's start with situation awareness. They found that the condition using the HUD with the SpearCon auditory feedback resulted in the highest level 1 situation awareness.
So HUD with sound meant they noticed hazards best.
Yes, most likely to notice and identify potential hazards. Conversely, the traditional HDD without sound led to the lowest level of this basic awareness.
Makes sense.
However, and this is a really important point, there were no statistically significant differences across any conditions for level 2 comprehension and level 3 projection awareness.
Ah, so seeing the hazard didn't mean better understanding or prediction.
Exactly. While HUD with sound helped drivers spot hazards more readily, it didn't necessarily translate to a better understanding of the overall situation or an improved ability to anticipate what might happen next. Perceiving is just the first step.
That's a key distinction.
Yeah.
Very interesting. What about the mental workload? Which system felt least demanding?
Well, across all 6 subscales of the NASA TLX mental demand, physical demand feeling rushed, and in the overall score, the HUD significantly outperformed the HDD.
Big difference for HUD.
Yeah, it strongly suggests that interacting via the HUD felt less mentally taxing compared to the traditional head-down display.
But what about the sound? Did the SpearCons help with workload?
Surprisingly, no. The presence or absence of SpearCons didn't have a statistically significant impact on reported workload.
Really?
It appears the visual display type HUD versus HDD was the dominant factor influencing how demanding the task felt. Just having the info in your line of sight seemed to make the biggest difference to effort.
So the HUD itself made it feel easier, sound or no sound. Okay. Now, menu navigation performance, speed, accuracy.
In terms of accuracy, they found no significant differences between any of the conditions. Participants were generally successful, about 85% correct, regardless of the setup.
Accuracy was consistent then.
But when it came to the speed of navigation, the HUD showed a clear advantage.
Faster with the HUD.
Significantly faster menu navigation times compared to using the HDD. So comparable accuracy, but quicker selections with the HUD.
Okay, so HUD seems faster and less demanding, but the eye tracking, what did that reveal about where drivers were looking? This sounds like where the trade-offs might appear.
This is exactly where we see the more nuanced findings. The eye tracking data revealed that participants using the HUD actually spent significantly more time visually fixating directly on the menu during selection compared to those using the HDD.
Wait, more time looking at the HUD menu than the traditional screen. That seems counterintuitive.
It does, initially. However, the other side of this coin is that participants using the HDD exhibited significantly more frequent and longer saccades, those rapid eye movements between the road and the menu.
Ah, so HDD users were looking back and forth more.
Exactly. It suggests that when using the HDD, drivers were consciously making more effort to frequently check the road, even though it likely interrupted their menu interaction and slowed them down.
Like a defensive check.
Perhaps. With the HUD positioned in their forward view, drivers might have felt they could keep the menu in their peripheral vision while monitoring the road, leading them to focus more intently on the HUD menu itself during selection.
Like they felt safer looking at the HUD longer because the road was still kind of there.
That's one interpretation, yes. Almost like with the HDD, they were constantly double-checking the road, whereas with the HUD, they felt they had a better sense of both, so they focused longer on the task when needed.
That's a really interesting, important distinction. Okay, so let's connect this to actual driving performance. Did one system lead to safer or more stable driving?
The driving performance data also presented a somewhat mixed picture.
Uh-oh.
The study found that using the HUD resulted in a lower average steering wheel angle.
Suggesting smoother steering.
It might suggest more stable steering overall, yeah. However, the HUD was also associated with a higher average lane center offset.
Meaning they drifted more.
They tended to deviate more from the center of their lane when using the HUD.
Why would that be? Because they were looking at the HUD longer.
That's the potential explanation. Spending more time looking at the HUD menu and perhaps less time making those quick glances at the road, especially on curves.
Okay, that's a concern.
And interestingly, again, the presence or absence of the SpearCon auditory feedback alone didn't significantly affect driving performance in either condition.
So, more stable steering with HUD, but also more lane deviation. A definite trade-off. Finally, what do the participants think? Which did they prefer?
The results from the System Usability Scale, the SUS questionnaire, showed a clear preference.
For the HUD, I bet. You got it.
The HUD received significantly higher usability scores compared to the HDD. Users found it easier to use, more intuitive, more satisfying overall.
And the scores reflected that.
Yeah, based on standard SUS interpretations, the HDD scored in the poor usability range, while the HUD scored good. This aligns with the lower workload and faster interaction times we saw. Users definitely felt the HUD was better.
That preference certainly fits with the speed and workload data. So overall, it sounds like the HUD has clear advantages, but, well, it's not a flawless solution by any means.
That's a perfect summary. The study gives strong evidence that HUDs can improve basic situation awareness, that Level 1 reduce workload, speed up menus, and users prefer them.
Okay.
But it also introduces important trade-offs, particularly in how drivers distribute visual attention and in their ability to maintain consistent lane positioning.
That longer fixation on the HUD menu, that's the worry, right? Missing things.
It raises a potential concern, yes. Missing more subtle or gradual changes in the broader driving environment because your focus is narrowed on the HUD, even if briefly.
It almost sounds like the very ease of use with the HUD might inadvertently create a kind of false sense of safety.
That's a very astute observation, and it's a possibility the researchers discussed. Like, drivers believe they can quickly glance back if needed, but their attention is more anchored on the HUD than they realize. They also pointed out that while the HDD might encourage more, let's say, defensive driving with more frequent glances back at the road,
Oh, yeah, it's a checking behavior.
it comes at the cost of lower basic situation awareness and worse performance on the secondary task, the menu interaction.
So neither is perfect as is. Given these findings, what are the key directions for future research? How do we make these systems safer and more effective for drivers like you and me?
Well, the study author suggests several important avenues. One key area is focusing on the design of HUD displays themselves.
How they look and present info.
Exactly. Leveraging their unique position to enhance overall situation awareness, not just spotting hazards. This could mean experimenting with different visual cues, colors, icons, text to convey info effectively without requiring that prolonged direct gaze.
Make it more glanceable.
Precisely. Another important direction is investigating HUD size and format more. Exploring full windshield HUDs, for instance, and their impact on distraction and response times.
Yeah, a bigger HUD could be better or worse, I suppose.
Needs investigation. This builds on some foundational research in the area.
Makes sense. A poorly designed or cluttered HUD could easily become just another distraction. What about the sound aspect?
They also recommend exploring more advanced auditory feedback, maybe using spatial sounds to indicate the direction or proximity of hazards.
Like 3D audio cues.
Something like that. Referencing some interesting recent research, this could potentially improve those higher levels of situation awareness, the comprehension and projection that weren't significantly affected here.
Okay.
Furthermore, they stress the need for future studies to use more complex, realistic driving scenarios. Evaluate these systems in a wider range of real-world contexts.
More challenging drives.
And finally, they point to the ongoing need to refine the gesture interaction systems themselves, maybe providing more direct visual feedback on finger position.
Which is a limitation here.
Which was a known limitation with the Leap Motion controller used and is a focus of other research, improving the feedback and logic.
So it sounds like while HUDs and gesture control with sound hold a lot of promise, there's still significant work needed in design and research to really optimize them.
Absolutely. This study provides really valuable insights into the potential benefits, but also the crucial trade-offs.
Well, this has been a truly illuminating deep dive. It's clear that while HUDs with gestures and sound offer compelling advantages, well, they aren't a perfect out-of-the-box solution.
Not yet, anyway.
Requires careful consideration, thoughtful design to ensure they genuinely enhance safety without creating new risks unintentionally.
Precisely. Understanding these subtle but important nuances is going to be increasingly crucial as these technologies become more integrated into the vehicles we drive every day.
So as we wrap up, here's a final thought for you, our listener. Considering all these findings, what specific aspects of in-car interfaces do you believe are most critical to get absolutely right for truly safe and seamless interaction while you're driving?
What's the priority?
Yeah. And what role do you envision advanced displays like HUDs playing in shaping that future of in-car technology? Definitely something to think about.
Mm.
If you're interested in digging even deeper, you can find the original research article in the International Journal of Human-Computer Interaction. Thanks for joining us for this insightful deep dive.